Algebra 1, Chapter 7, Section 1, Zero and Negative Exponents. Circle the exponent in each equation. Well, the exponent is the number the base is being raised to. So in the first one it's 5, in the second one it's a 2, the third one it's a 7. Write an equivalent expression using the exponent. Well, the exponent tells us how many times something is being multiplied. So we are multiplying the 35 3 times. So this is 35 raised to the third power. We're multiplying 19 2, 3, 4, 5, 6, 7, 8, 9 times. So the answer is 19 to the ninth power. In the expression 4 raised to the third, the base is the number 4. That's the item being multiplied, where the exponent is the number 3. So what exactly is an exponent? What does it tell us? Well, an exponent is something that tells us how many times we're going to multiply the base. So we can take any base, for example, x, and raise it to any exponent, for example, in this case 4. That tells us that x is being multiplied 4 times. So looking at these expressions below, we have 3 squared. That means we're multiplying 3 2 times. So that means 3 times 3, which of course equals 9. And in this case, we're simplifying 3 squared. When we go to 3 cubed, right below it, we get 3 times 3 times 3, which is 27 when it's simplified. Now, if we involve negatives, as we did in this case, we need to remember that this only affects what's directly in front of it. So the only thing being cubed is this 3. So we have negative 3 times 3 times 3, which is negative 27. Now the following example is slightly different because what's directly in front of this 3 is a parenthesis. So it's going to affect everything that's inside the parenthesis. So in this case, we have negative 3 times negative 3 times negative 3, which is negative 27. Our vocabulary word is negative. A negative quantity has a value less than 0. So if we have, for example, a temperature 4 degrees below 0, well, that's negative 4. You owe your brother $8. It's a negative 8. A worker's hourly pay increases by 50 cents. Well, that's not negative. That's going to be a positive. Increase is positive 0.50. Looking at the problems below, we want to draw a line from the negative number in column A to its opposite in column B. Well, the opposite would be its positive value. So 1/2 and negative 1/2 would be opposites. Negative 3 3/5 and positive 3 3/5 would be opposites. And likewise, negative 17 and positive 17 would be opposites. Let's talk about some properties of exponents. If exponent is ever a 0, that means it just equals 1. So no matter what the base is, when the exponent is 0, the value is 1. Here's another property of exponents. In this case, we're going to talk about negative exponents. So for every non-zero number a, so any base that's non-zero, if we have a negative integer, that simply means we're going to use a reciprocal of that value. So a to the negative n is a reciprocal of a to the n. And likewise, a to the n is a reciprocal of a to the negative n. So here we have 3 to the negative 3. Well, this negative sign means 1 over 3 cubed. Notice how it became the reciprocal and the negative sign went away. So that value would be 1 over 27. This is kind of a review of the whole unit. For 0, any base raised to the 0 power equals 1. Anytime you have a negative value, it becomes the reciprocal and turns positive. So anytime you have a negative value, you put it in the denominator and your exponent becomes positive. So in the bottom one, you have negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So you'd have 1 over negative times negative is positive times negative is negative times negative is positive times negative is negative 243. So write true or false for each of the following. 12, well, The negative tells us denominator, and 9 squared is 81, so that's true. Anything raised to 0 power is 1, not negative 1. So that's going to be just 1. This negative does not make it negative here, so that's false as well. It would just make it 1 over 9. And the last one is true. Notice a negative exponent only means that the base goes in the denominator. It does not turn the value negative. So what is the simplified form of each expression? Well, for an exponent to be simplified, it must have a positive value. So looking at the first problem, this is not simplified. To make the negative 9 positive, we put 1 over x to the 9th, because the negative exponent means reciprocal. In the second problem, the reciprocal of n negative 3 when it's in the denominator is to move it to the numerator. So this would be n3 over 1, which would simply be n cubed, or n to the 3. Remember, when we use the reciprocal, that negative exponent becomes positive. In the third problem, you need to remember that this expression, this negative 3, only applies to that c. So the 4 and the b both have positive exponents, so they stay where they're at. And the c, to make it a positive exponent, needs to move it to the denominator. The next problem, we have 2, and the a is going to move to the numerator, so it has a positive exponent. And in the last problem, we need to move the n to the denominator. And notice I put them in alphabetical order. The m came first because it comes first alphabetically. So to simplify a base in the numerator that has a negative exponent, move the base to the denominator and write a positive exponent. Likewise, to simplify a base in the denominator that has a negative exponent, move the base to the numerator and write a positive exponent. To write exponents in simplified version, they must be positive. Now, when we're finding the value of an exponent, we have two methods. When we want to evaluate an exponential expression, we have two methods we can use. The first one is to simplify first. And the second one is to substitute first. And we're going to go through both of these. So we're looking at n to the negative 4, w to the 0. Let's simplify first. So we're going to take the n to the negative 4, we're going to make it n to the 4 by putting it in the denominator. Now let's substitute. W is equal to 5. So we have 5 raised to the 0 power, and we have negative 2 raised to the 4th power. Well, 5 raised to the 0 power is 1. And negative 2 raised to the 4th power equals negative 2 times negative 2 times negative 2, and I'm running out of room, but times negative 2. So these two together make a positive 4. These two make a positive 4. 4 times 4 is 16. Now you could also substitute first. So take n to the negative 4 and make it negative 2 to the negative 4, and then w would be 5, so it's 5 to the 0. So we've substituted. 5 to the 0 becomes on top, and negative 2 to the negative 4 becomes negative 2 to the positive 4 by using the definition of negative exponent, meaning we use the reciprocal. 5 to the 0 power is 1, and as we've seen before, negative 2 to the 4th power becomes 16. On this slide and the remaining 9 slides, 10 including this one, I want you to go through and attempt to solve these. Stop the video. Have you tried these? I hope so. Okay, for this first problem, we need to realize that this part of the problem is raised to 0 power. So that means that part of the problem becomes a 1. The negative stays in front because the negative wasn't raised to 0 power. It's outside the parentheses. So my answer is B. Okay, in this problem, we have the parentheses, and we have the negative 2. Now remember, the negative means to put, or to use the reciprocal. And then the exponent will become positive. So this is going to be 1 over negative 5 times negative 5. Well, obviously, negative times negative is positive, and 5 times 5 is 25. So it'd be 1 over 25. Did you choose A? Looking at this problem, we know that the negative exponent tells us to use a reciprocal. So this is 2 to the 6th. So we know our answer is going to be positive. We just have to determine what 2 times 2 times 2 times 2 times 2 times 2 is. Well, 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, 16 times 4 is 64. Looking at this problem, we know that anything raised to the 0 power is 1. So this problem becomes 1 over 1. So the answer is C. As we evaluate this problem, we know we cannot have a negative exponent. So that means that 5 to the negative 2 is going to become 5 squared in the denominator. The p has a positive exponent as a 1. So we're going to leave that where it's at, and our numerator will become 1. To simplify this further, we know that 5 squared is going to be 25. And that'll be 25p. So C is our answer. When we go to simplify 9 raised to the 0, y to the 7th, t to the negative 11, we have a couple of steps. We know anything raised to the 0 power is 1. So this becomes a 1. Y to the 7th stays y to the 7th. T to the negative 11th becomes 1 over t to the 11th. Now knowing these are all multiplied together, this becomes 1 times y to the 7th, that's y to the 7th obviously, times 1. So you're multiplying this, this, and this. And then your denominator is t to the 11th. So this is the answer to this problem. Evaluate the expression for r equals negative 3 and s equals 5. Well, there is no r, so we're only going to deal with the s. So this becomes 2 times 5 squared. Now remembering that this squared only applies to the s value, or in this case the 5, not to the 2 in front of it. So this becomes 2 times 25, which of course is 50. Again, we're evaluating this expression for r is negative 3 and s equals 5. In this case, we only have an r value. So we have negative, our r value is negative 3 to the negative 2. Now remembering that our exponent applies to everything in front of it, and as I've taught you, whenever you replace a letter with a number, use parentheses, you see that negative 2 applies to both the negative and the 3. So this becomes negative, and the negative exponent means reciprocal. And then we have negative 3 squared. So we have 1 over negative 3 squared is negative 3 times negative 3, which is a 9. So our answer is negative 1/9, C. Here is your lesson check. Do your best on this and bring any questions you have to class tomorrow.